What's up, hackers? Welcome to Saturday Hacker Day. My name is Taggart, and today we're going to be doing some blue team work, getting our hands dirty in our home lab. But before we do that, as always, we're going to do a couple of stories from this week in cyber news. Up first, Microsoft fixes patches for CVE 2022-26923 and 26925, I should say. Now, this was kind of an issue. So during this last Patch Tuesday, the second Tuesday of the month, if you're not familiar with that term, Microsoft released updates to Windows and Windows Server operating systems, and one of them addressed a long-standing vulnerability in the way that Active Directory Certificate Services handles Active Directory certificates. And this allowed essentially a machine account spoofing attack to allow authentication as a domain administrator at the very least. And there are also a few other attacks that allow things like local privilege escalation to system. Okay, so this patch was released, but unfortunately the way that they handled the patch damaged, why did I use that term? Impacted authentication for certain protocols that are that are commonly used in environments, particularly things like Radius and also EAP and PEAP. Now, if you're not familiar with these authentication protocols, don't worry about it, but the TLDR on this is it's very likely that if you have your wireless, especially, but other kinds of Internet of Things devices and also appliances like network switches, if you have authentication to those devices, but wireless controllers in particular, if you have those hooked in to Active Directory authentication in any way, shape, or form, odds are they're using one of these protocols. And so it's very likely that this update may impact your wireless controllers. Now, here's the good news. As of 2 days ago, I think, maybe 3 days ago, Microsoft has released an out-of-band update to fix this issue. So if you have installed the updates and you're having issues with this, you can go get this latest patch from Microsoft and get that installed on your, I believe it's going to have to be both the domain controllers and the certificate authority servers if they are different machines. Yeah, but certainly the domain controllers. Hey, Smithy, thank you so much for the resubscription. Really appreciate that. All right, so that does it for our first story. Just make sure that you update those patches if you have that issue in your environment. Okay, this next story, settle in because this is a whole thing. This week we saw an announcement from the threat intel group Advanced Intel, and I'm going to link the write-up here, that Conti is quote-unquote dead, and that instead of the Conti ransomware gang that most recently has essentially brought the nation of Costa Rica to its knees with a really, really aggressive ransomware operation. The report suggests that Conti, given the initial fracture that we saw in the group after the beginning of the war in Ukraine, and the leaders of the Conti group's outright support for Russia and the subsequent leaks of information we saw, they had a damaged reputation and consequently have been spinning up these small independent groups that will still offer the same services as Conti, but with a different brand because of the reputation hit that Conti has taken over the last several months. Here's the thing. If you read the report carefully, I don't know if so obviously I don't have access to the same intelligence that these folks do, right? They're looking at actual posts from Conti leaders on the dark web and elsewhere, and I don't have access to all of that. But given what is presented in this report, I am skeptical that this is the end of Conti, and here's why. If we look at the report, there are several times where the analyst is bending over backwards, I feel like, to make the evidence fit the hypothesis, or to put it another way, make the wish be the father of the thought. I want Conti to fall apart too, but I don't know that that's what's happening. For example, you have some situations like, first of all, whenever you quote Sun Tzu in your piece, you've already jumped the shark, but that with this Conti attack against Costa Rica, that would suggest that maybe Conti is still up and running and doing fine, right? But the analyst's report on this says, quote, Advanced Intel's unique adversarial visibility and intelligence findings led to what was in fact the opposite conclusion. The only goal Conti had wanted to meet with this final attack was to use the platform as a tool of publicity, performing their own death and subsequent rebirth in the most plausible way it could have been conceived. What? What does that even mean? If they have the capability to perform this attack, and they clearly did, from a business perspective, does Conti have a reputation problem? I'm not convinced that they do. And so it seems to me that they're trying to make the evidence fit the hypothesis, again, saying, oh, well, all of these smaller groups are going to get spun up and Conti is going to disappear. But I have no reason to believe that based on what I've seen in here. And of course, they do kind of qualify this at the end, saying that the end of the Conti brand does not equal the end of Conti as an organization, which I believe is in fact the case. But I also have no reason to believe that Conti as a brand is going anywhere. It is incredibly well known, and I don't really know what kind of reputation hit they have suffered when clearly they still have the capabilities that we would ascribe to the Conti group. So take a look at this report. See what you think about it. I'm not convinced. I'll also say that there's just something that rubs me the wrong way about a threat intel report that has too florid prose in it. Quoting Sun Tzu, never a good thing. But this last paragraph really feels like somebody was a little too a little too over their skis, as it were, with this, where it says, looking back, a trail of similar marks led from the group's days as the organization Ryuk to their first rebranding from the collective's Overdose division. Each mark represents a shift in the threat landscape, a series of ties that, only when viewed from a great distance, show the dramatic impact the group has made on ransomware's very existence. However, the actors that formed and worked under the Conti name have not and will not cease to move forward with the threat landscape. Their impact will simply leave a different shape. That's like the kind of paragraph that I would have written when I was coming out of college as an English major and was too arrogant for my own good. So, I don't know. Just something to think about with this report. Feel free to read it for yourselves and see what conclusions you draw. I am not convinced, based on what I've seen, that Conti as an entity is going anywhere, and certainly the services that they offer are here to stay. Okay, we are moving into our main work for the day, and basically what we're doing today is we are trying to get packet capture across the board to work in our Proxmox virtual lab. And this has been a bit of a challenge for a couple of different parts of our build, for Suricata and for Zeek. And if we can sort this problem out, we'll have this issue resolved, and we'll understand how to do this correctly in virtualized environments like this. So let's dive right in and take a look at where we are so far. All right, so when we last left off, we had successfully deployed a Suricata server, and we also have we have our OpenCTI system up and running, but we're not too concerned with the OpenCTI system today. We're mainly focused on packet capture issues. And we also have a machine, I believe it's Linux Infra, that is doing Zeek for us. If it's not there... Oh, you know what? It actually might be on the SOC itself. Yeah, it's on the SOC itself. And this is doing Zeek. The problem in both cases, though, is that packet capture doesn't seem to be playing ball. There are a lot of reasons why that can be true. What do you need to do in order to get packet capture to work in a networked environment? So part one is that your network interface on the machine that you're trying to capture on has to be configured in what's known as promiscuous mode. And what that means basically is that if there are packets sent to that interface that aren't tagged as being for that MAC address, then it's going to ignore them. And that's the way that interfaces are designed to work. So like generally speaking, upstream, your network switch or your router or whatever is trying to do its best to make sure that packets that aren't intended for you are ignored, right? But that work doesn't just rely on the upstream switch. Your network interface is also analyzing packets and saying if the intended MAC address is not meant for me, it'll discard it. Okay? And in fact, that is generally the case in wired environments, but in wireless environments, that has to be the case. Because in wireless networks, every packet is sent to everything. Okay? Right? Like the wireless controller is just an antenna, right? It's a broadcaster. It doesn't have a way of doing a specific allocation. The wireless access point cannot send a specific packet to a specific wireless host, right? It's broadcasting, right? That data, right, over the radio. And so it's not like every machine has its own channel on the radio that it's using. That's not really how that works. And so, in a way, wireless network adapters are in what is called promiscuous mode. Not really, but they're accepting packets from everywhere all the time anyway, and then discarding them if they're not tagged for the right machine. So enabling promiscuous mode in a wireless environment is like one click and you're done. Because once you enable promiscuous mode on your wireless interface, then you get to do cool stuff like PCAP-NG, and you get to start capturing all the data that's going across that wireless environment. It's very easy to do. In a wired environment, there's an extra step, which is that you have to make sure that the upstream switch port or whatever network interface that your computer is connecting to is also sending all of that data to your network interface. And that isn't by default the case. Hey, nice guy. Thank you so much for the follow. So what we need to do is come up with something called, or configure what's called a span port or a mirror port. And that mirror port is basically going to say, okay, everything that is coming into a network interface or going to a network interface, we're going to mirror all that traffic over to another network interface. That's the basic idea. Okay. And in a Proxmox environment, the way that I have this configured, I'm doing this with, I have our networking set up with something called Open vSwitch. And Open vSwitch has the capability to do this. It's just really, really weird and confusing to look at. But before we start configuring that, I want to show you what the problem looks like and how you can identify it when you run into this. Okay, so I am here, I'm SSH'd into both the SOC machine, because in case I need to, and then here in the Suricata machine, which also is, both of these are theoretically supposed to have PCAP interfaces. Let's look at the PCAP interfaces in both cases here. Okay, so in this one, I've actually set ENS 120 to promiscuous, which is not set up by default. This is kind of problem one, which is there is no way in NetPlan, which we've seen before, right? If we cat etc netplan, this is the network configuration that we have for the machine, right? And you can see this ENS 120, I have it set up to DHCP. There is literally no way with NetPlan to configure a network interface to be in promiscuous mode. You can't do it. You just can't do it. And so you have to use other tools to make that happen. And that looks a little like this. There. So sudo IP link set device ENS20 promiscuous on. Now, that's kind of annoying to do that every time you set up a machine. So there are a couple of ways that you can do this automatically, and we'll get to that in just a moment, how to do that the right way. I think it's a systemd service. Other people may disagree. But let's get this command running on this machine here. Because in theory, I was under the impression that Zeek and Suricata would handle the setting of promiscuous mode on these interfaces. I'm not convinced that's true, because I've never seen it actually capture the right way. Okay. All right, now you can see that we've got the promisc tag here for our ENS 20. Okay. Now, if I want to see, forget Suricata, forget Zeek, if I just want to see what this thing is capturing, what tool do I have just out of the box that I can use to take a look at what my interface is seeing? And happy Saturday, Michael. Good to see you. Come on, where's that audience participation? What tool do I have on a Linux machine right out of the box that I can use to take a look at what that interface is seeing? All right. The answer is TCP dump. TCP dump is our packet capture tool that comes out of the box on most Linux distributions. And all we have to do is take a look at exactly what TCP dump is seeing. So I'm going to do this with no filter. TCP dump interface ENS20. I want to see what this interface is seeing. Now, by default, this is going to dump to the terminal. I could also write it out to a file, but I just kind of want to see it at first. And then if I need to pull it and look at it in a Wireshark, I can do that as well. Pretty dang quiet, right? Let's give it some traffic to maybe see. So I'm going to connect to the desktop over RDP. Now, we're getting packets in. Take a look at what these packets are there. They're UDP. We can see that they're coming from 192.168.99.17 to 239.255.255.250. This is, multicast. And then we see some jump box, right? There's some IP6. Good. But look at the protocols we're seeing, MDNS, and look at the destinations, 224. Again, these are multicast addresses. I'm not seeing destinations for a specific destination. And even once I'm on this machine, right? If I try to go to 10.1. Hold on, let me bring up PowerShell. If I try to do like ping our domain controller, 10.1.99.3, am I seeing ICMP traffic here? Am I seeing that ping traffic? If this were capturing all the data going on inside that isolated lab switch, I would. But I'm not seeing that. What I'm seeing is MDNS traffic, mostly, almost exclusively. It's a multicast DNS, and that's kind of it. And the reason I'm seeing that is that these addresses, packets intended for these addresses, are by design sent to every interface on the switch. That's the point of multicast, right? Without configuring different multicast groups, and then broadcast as well. So consequently, if this is all I'm seeing in TCP dump, I have every reason to believe that somewhere along the line, I missed a step in terms of making sure that all the traffic that's supposed to go to this interface is going to this interface. And I know that this interface is in promiscuous mode, where we have some DHCP traffic as well, which again is going to be broadcast everywhere, because that has to be, right? And ARP as well, right? We're going to see ARP, because again, those things don't rely on specific IPs. Okay, we'll Control-C this. You can see now, if I'm only seeing traffic that is intended for everybody and not for specific sources and destinations, I have reason to believe that I missed something. So, what did I miss? I believe the issue is up here at not the network interface level, but in fact at the networking level here in Proxmox. And let's look at our network configuration. I have four physical network interfaces on the server, but the only one that I'm using really is EN01. This is my uplink to my local network and then eventually to the internet, right, through my house. This bridge interface, EN01, this right here is the bridge that connects, that links this active network connection to a virtual interface that allows me to basically bridge connections. Bridges, by the way, so Linux bridges, bridge connections, and then bridges in OVS are essentially virtual switches. That's the best way to think of them. So I have these two here, this VMBR1 OVS bridge and VMBR2, this OVS bridge. You can see that they have specific CIDRs that they're set up for, and they have names, right? SecLab Internet, this is the one that I use for my infrastructure. It does have internet connection by default. And then we have isolation, which doesn't. Okay, so then if I wanted to capture traffic, even internally in the isolation network, how do I do that? This is where it gets a little confusing. I have found some documentation on how to do this, but I have to do it on the command line with this thing called OVS VSCTL. And here we're looking at a span port. And I found some other documentation of other folks who have figured out how to do this. But it's not simple. I'm going to take a look at one of these resources, and I'll link this here in the chat. From Arthur Chow. This is a little bit dated, but it was updated. It was originally published in 2018. It was updated in 2021. And this is talking about traffic mirroring or port mirroring. It's a technique to send a copy of the network traffic to a backend system. It's commonly used by network admins who need to monitor the network traffic, diagnose network problems, blah, blah, blah. So, intrusion detection system, right? So this is how we need to do it. An OVS bridge is a software implemented layer 2 bridge, which is important, which means it's aware of MAC addresses, not IP addresses. A port is a virtual device which can be used by a NIC as applications to send and receive packets. OVS provides a way to duplicate network traffic of specified ports to a dedicated output port. The duplication could be in single direction or both. Then we have port mirroring with Linux bridges. There's this article which may come in handy here. But the first thing we're doing is we're adding a port. This mirror port here. Then configure our mirror. An anonymous gifter, thank you for the tier 1 sub to Smarty Pants. All right, so let's start playing with some of the command line stuff with OVS VSCTL, because obviously we're going to be spending some time in there. We're going to go to the shell right here. And I think we're going to start with OVS VSCTL show, because that shows us everything that is set up in the environment. And it is a little hard to get at first, because obviously we have these ports that have been configured, honestly, by Proxmox for us when we've created virtual machines, right? When we spin up VMs, it creates these ports on Open vSwitch for us. It's handling that for us. I have not manually assigned specific bridge ports to specific network interfaces on my VMs. But it seems like I may have to do that for this. Okay. And they all have unique IDs. So if I wanted to see what this last port is, if I do... Of course I did that. I'll just copy that way. Is it get port? Lovely. Well, let's list the bridge then. And let's do exactly what we did have here. So OVS-CTL list bridge, and then we'll do the bridge that we have. Just so we can learn our way around this thing. VMBR2 is our internal. Okay. Here are our ports. Here are the IDs of them. Interesting that they're in an array like that. And no mirrors. A thing to note, besides the awkward command names, is that in Open vSwitch, absolutely everything can be referenced. Absolutely everything that can be referenced has a UUID. This is by design. In this case, we see that the switch has 3 ports plus the internal port that is created by default, whose UUIDs are shown in the ports field. Yeah. Okay. Oh, Theo, thank you so much for the raid. Welcome, Raiders. Good to see you all. Theo, how was your stream, my friend? Hey. So, folks who are just joining us, what we're doing today is we're taking the next step in setting up our home lab with an intrusion detection system and intrusion protection system, Suricata in particular for the IDS. And in order to do that, since we're using Proxmox, we have to create a mirror port. Actually, more than one for our purposes, but we have to create a mirror port that allows traffic to span from one part of the virtual switch to another so that the packet capture interface is able to pick up all the traffic that we want. Daniel, thank you so much for the follow. Painfully learning Splunk. You know, it's a good hurt. It's a good burn. I like Splunk. I really do. Although I have to say, having spent some time now in Sentinel, Azure Sentinel, the KQL has kind of stolen my heart. It's a really powerful query language. You told everyone you were a Blue Team Ninja? Oh boy. Well, prepare to be extremely disappointed for today, because what a lot of today is going to be like Linux sysadmin hair pulling. But the idea eventually is that we'll be able to get, because we have our Elk stack up and running, but I want to get Suricata data coming in to our Elk stack that we've configured. So that's kind of our first part. And in order to do that, we have to kind of become a network engineer for a little bit. Oh boy. Okay, so that's the plan. Let's see. So in order for us to create a mirror, we use this command, which is awful. This syntax is terrible. The syntax may look a bit awkward, but it's not complicated. Yes, it is. We're running 2 commands at once. Each command is introduced by the --, because ---- is like taking... Okay. So the first command creates a mirror named myMirror. And thanks to the ID equals @m part, saves its UID in the variable @m, which remains available for later commands. and we use it indeed. Did Teal'c write this? Which associates the newly created mirror, my mirror, with the bridge OVS BR0. Okay, so I think we can basically pull this right off. I'm going to put this on another screen so I can see it at the same time as typing. Okay, so we're going to do OVS CTL, OVS dash VS CTL dash dash, and then ID equals @m to save the UUID. Create mirror name equals isolation mirror. Hopefully I can use underscores. And then dash dash, and then add bridge VMBR2 @m. So we're connecting a mirror port to this bridge. Although it would probably help if this were not equal signs and instead were dashes. Oh, so you're using Open vSwitch as a switch instead of using pfSense. Wally Wonka, Open vSwitch is a switch. pfSense is not a switch. pfSense is not a switch. pfSense is not a switch. pfSense is a router. And so, in fact, the router is subsidiary to the switch in this case. Because well, in a way, the router has two sides. It has the wide area network, the WAN side, which has uplink to the internet, and then it has the local area network side. Right? And so the router in this case is connected to at least one Open vSwitch. So it's not that I'm using it instead of, I'm using them together. Add bridge VMBR2 @m. Add command requires at least 4 arguments. What did I miss? Ah. I have to give it the place I'm adding it, which is mirrors. And now, sure enough, we have added a mirror to our VMBR2. Oh, I see what you're saying. I see what you're saying, Wally Wonka. So the issue there is that if I were listening, fair enough, if I were listening on the router, on an interface that I'd configured on the router, I could do a span port there and it would work just fine. But that's actually not the case. I'm using a span port that is within the network created by an interface in the router. Hey, Owen, good to see you. It's not a bad idea per se, Wally. It's just that my network architecture isn't working specifically that way. This might well, I don't know if it's nicer only because I'm separating my concerns. That's part one. This might warrant a drawing. if you'll indulge me for just a moment. So let's quickly review how this thing is set up. All right, I don't have any cool switch symbols here. That's fine. So I'm just going to basically be like, all right, the interwebs. Then up next comes physically. So this is going to be a physical device. The Proxmox server. It's an HP ProLiant. Right? So it's like a physical server. It has a physical interface on it. All right. So that's step one. Inside the Proxmox server, I have 2 V-switches. Okay? And what do I want for switches? Let's do parallelograms. Trackster, thank you for the follow. So I have 2 V-switches. They don't need to be that big. Okay. Boom. And boom. Okay. So this one is called internal, and it has internet access. Okay. And this one is called isolation, and it's not supposed to, unless I want it to. I know that the arrows don't match. Bear with me. It's sort of better. Okay. Now, let's talk about hosts. In terms of hosts, the first thing I have is I have my pfSense router. And the pfSense router has 2 interfaces. One of which, actually it has 3. But, no, just 2. And the pfSense router has... No, my bad. It actually does have 3. It has a WAN, and then it has 2 LAN interfaces, basically. So the WAN interface... Let me... Can I just get some text? Yes, thank you. This is it would technically be the WAN interface because it's a link through. Okay? And then I have 2 LAN interfaces. One of them is called LAN, the one connected to the internal vSwitch. And then the other one is called isolation. This creates, and this is the router that is handling that traffic. This creates, you know what, let me be more explicit here. So the LAN is on 192.168.99.0/24. That's the subnet that it has. Okay. And if this is a rehash for people, that's fine, but I think it's worth, talking about how we've built this out. And then this one is the 10.1.99.0/24 subnet. And they're totally separate interfaces on the pfSense router. Okay? So that I can perform different firewall functions on these different interfaces, and then this one I can allow to have uplink to the WAN, and then up it goes. Okay. Then, subordinate to this, and in this network, right, I have... So I have this internal LAN that is here and is upstream and gives me, and here I can put in my Ansible server. I can put in my jump box whatever else I want, right? And this is the one that has access to the internet. In this network, why would you do it that way? In this network, in the isolation, this is where I've put things like the domain controller, where I've put Windows hosts, and generally like lab machines that I'm going to do stuff to. So broadly speaking, infrastructure lives over here and isolation lives over here. Now the jump box, if I were to do individual hosts here, the jump box does have a cross-link. It has two interfaces. Again, one of which is here and one of which is here. So it exists in both networks. All right. So if I have something in the isolation LAN and I want a packet capture to it, what I need to do is I need to configure the switch here to handle that mirroring. Why is that true? Because if I were to do mirroring here, if I were to do the port mirroring that I can do on pfSense, is I can say, okay, mirror traffic from LAN to isolation. That's a terrible idea. I don't want to do that. Mirror traffic from WAN to isolation. Also a terrible idea. I don't want to do that. So the mirroring that I can do on pfSense isn't actually what I want. In isolation, what I can do is say, okay, mirror traffic from my egress port or from my pfSense or my gateway, whatever, mirror traffic from there to whatever interface I've connected my packet capture device to. And that's what I'm trying to do. Did that make anything like sense? Network engineering is pretty wild. Okay. So to make that happen then, so we've created the mirror, and then we have to figure out what source port we're actually going to use. And this is the part that I think is a little bit tricky. John didn't follow the last part. Okay. Let's try that one more time. The isolation, this isolation switch is like a switch, like a physical. It's one of these, but virtual. Okay. And what we're trying to do is, let's say I have, this is my uplink port, right? This is what connects to the router and then provides uplink to whatever. What I'm trying to say, and let's say this is my packet capture port. What I'm trying to do is say anything that goes through here, switch, you are also going to set a copy to this port. And if I have my packet capture interface connected to this, it'll be able to see all of that traffic coming through the trunk. That's what I want to do. But I can only do it by configuring the switch itself. I cannot do it at the router because the router doesn't know about what's connected to what on the switch. Cool. Okay. Now the trick is I need to be able to figure out which of these network interfaces is the one that I want. You know what I mean? Like, how am I going to figure which of these Open vSwitch machines is the right, which of these Open vSwitch ports is the one that I want to connect? Thanks to previously introduced, we can configure the same thing without VNet 0. Okay, these are the ports that are configured on VMBR2. Can you see learned MAC addresses of that port ID? That is an interesting question. Let's go back to OVS VSCTL and get our help just to see what else maybe we can. That's a great idea. List ports. Maybe there's another place we can do it. Because we have other OVS controls. Nope. Looks like VSCTL is the only one. It's really going to do it for us. That's a good question, though. Because that's exactly how I would do it in a Cisco switch, right? I'd get a MAC address table. Yep, exactly right. Exactly right, Traxxer. Same page. There it is. Use the OVS appctl FDB show command to... Okay. Is that a thing I have? Yes, I do. Oh, cool. That's handy. So let's learn what OVS appctl can do. List commands. It was FDB show, and then we need the bridge. So FDB show, and then the bridge would be VMBR2. FDB show VMBR2. OVS is Open vSwitch. Tani, yes. Okay. I love the age. Oh, really? So Proxmox uses it as one of its two options. You can either do Linux bridges or Open vSwitch bridges to create virtual switches. Yep. Now find the host that you want as a source and look up the MAC of it. Yep. That's exactly right. Cool. God, it's been a minute since I've had to do layer 2 stuff. It's kind of fun to do again. Oh man. This used to be how I would hunt down, this is a total aside, but showing MAC address tables is how I used to look up lost laptops and iPads when I was a school administrator, because I had a good mapping of like where my wireless access points were, right, from a switch port perspective. And so if a student came to me and said I lost my device, I could say, okay, I could look it up in my MDB, and the MDM. The MDM would give me like a general location, but it was like it was at the school, right? So I could then take the MAC address as reported by the MDM device and then look it up in the MAC address table and identify essentially what wireless access point it was connected to, and then give like a general vicinity of where the device was. Linux bridging is a pain. Take it from an ex-Red Hat admin. I believe you. Yeah, I didn't want to do too much Linux bridging for that reason. I wanted to do as much as I could with Open vSwitch. That sounds like magic. It was a fun trick to pull off when it worked. But it was only possible because I had the solid mapping of access points to switch ports, which is, I think, the real magic, is having a solid a device and network architecture inventory that's good enough to do that. Okay, so this is probably the MAC address I want, but I'm going to log into pfSense anyway and just check. I think pfSense will show me the MAC address of the interface here. If it doesn't, I'll go to the shell and just get it. Interface. I ended up passing the NIC hardware through to pfSense. I'm not sure what you mean by that. Ah, I am going to have to get it directly from the machine. That's fine. Oh, you mean do a solid bridge to pfSense? I did too. For that part. I created a direct look. You see this right here. Well, okay, so look, this is what I have. I have a bridge for my WAN. I do have that. And I think that might be what you mean. So I do have that part, but then for my two switches, I wanted Open vSwitch to manage those. Give me the shell. And I need the EM2. There it is. CE2A A6995690. I'm just saving that. Okay, going back over to our system shell here. Yeah. Awesome. Port 1. But that's, so how does that relate to, so port 1. And then this one here is going to be Interestingly, I don't see it. I should be seeing 1A08. DAD7, 60B3. This one shows fine. But interestingly, I'm not seeing 1A. Am I just missing it? Five two 4A. This entire machine is like not showing up on this switch. Thank you. Right, of course, that's right. It's only Proxmox virtualizes the max, but it still works. That's right. If you're just listening for traffic here, it won't show. That's right. When Linux gets the packet and doesn't have a flow configured in the kernel, it bubbles the packet to OBS and then it pops up. OBS configures the flow in the kernel. It doesn't need to send back to OBS every time. Y'all are too smart for me. The problem that I have right now is that I need to identify which of these ports is which and create the mirror accordingly. And in fact, I still have a problem because there's no correlation between these. Unless it's right here. 679. No, 8, interestingly. That might be the correlation, but I have no reason to be sure of it. Let's see what else appctl can show us, because that might actually help us out. Oh, right. We're going to do list commands. I want to point out that this is insane, right? If you're, let's say you're not like a Linux system administrator, and a pretty good one at that, or a network engineer, if you're like a security person who's trying to set up a home lab, doing it this way is like, it's tough, right? It's not really reasonable to expect people to be able to just pull this off. I love that none of these actually give me any information about what these mean. Multicast, no. Okay, so that's multicast. Ah. Here we go. It's not that tough in general. You just have to realize it with different stuff. Record scratch.wave. Yes, it is. It's not tough for you, Trackster, because you have all of this experience in this field that makes it not hard for you. And just as an FYI, if you are, before anyone is like, oh, it's not hard, you just have to, if you're constructing a sentence like that, stop. Just stop. Because it might not be hard for you, but it may objectively be complex. And if you don't have the requisite prior knowledge, it can be challenging to dive into it, especially when there's an expectation that you should. One of the reasons we're doing this home lab is that there is an expectation amongst security professionals to have this kind of setup in their house, which is in itself bananas, because it's a massive investment of time, energy, literally electricity, and also effort, and then financially. Just to have this as part of something that you do outside of your job, it's a little crazy. I'm doing it because I enjoy it and I want to share this knowledge, but it is objectively difficult, and especially when you get to this part of it, you know, when it requires this unbelievable cross-disciplinary knowledge, yeah, it is in fact not easy. I don't mean to jump out on that too hard. It's just that I want to be mindful that people can struggle with this stuff, and when you say stuff like, "Oh, it's easy," it devalues their effort, and it doesn't acknowledge the reality of the struggle that they're putting in, myself included, by the way, because this is hard, and I gotta tell you, like, I'm pretty good at this stuff, but this is not simple. Okay. So we have these port listings, and if they were brought up in order, we would have a reason to believe okay. 100 002. So this is, I think, our upstream. And this, so these are our two first ports, and then 101. So 100, I believe these are the interfaces that are the uplinks, basically. So this is the one that I want to bridge. And then the last one here, 115.01 and 115.02. Yeah. Okay. So I think I'm trying to make a bridge from here. 10. Although it has 10 and 11. It's 104, 109, 111. FWLN 02, 01. Some of these show 02, and I don't know why. All right, I think I'm trying to make a bridge from here to here. That's what I think I'm trying to make. So if we look at the documentation for this again, we have this set mirror that's really tricky. It says, is the UUID of VNet 0? Select source port. S6 and then select desk port. Okay. What's this get port situation? I want to learn more about that. Oh. I have to give it the... Oh, right. Let's do it this way. Should I not be seeing output? I guess it just expects me to be hyping this thing, so... Okay, hang on a second. Now that we have mirror created and in the bridge, we should configure its source and destination ports. We want to mirror all traffic going in and out of port VNet 0, which we actually don't have. I just want to do one more look here. Proxmox. I want to see if there's a thing about assigning. See you, Wally. I'm going to list the... Yeah, it's not really going to help me out here. Okay. Sorry. So let's go back to... Yeah, they wrapped all this in scripts, but this is the source. So let's go back to where we created these things, because they did port VNet 2. Is it just me, or does a lot of trial and error happen at this point of my setups? Yeah, maybe it's just me, John. I feel like this is kind of how it goes for a lot of these home lab setups, and maybe it's because I'm not as skilled about it as I should be. But yes, there is. Because I'm working with a lot of technologies that are new to me. I'm learning along with you. It's not the difference between this and like a YouTube video that's cut and edited is that you get to see all the stuff that doesn't work. Okay, so they've pre-made these interfaces. So we've created the mirror. So I think, John, what you're seeing is that the best people you've worked with cut through the stuff like warm butter because they've done the hard stuff without you present. I'm pretty sure that's how that goes. All right, so we're gonna do this again. We're gonna the OVS not here. All right. So basically, I'm taking this port and mirroring it to the last port that I've made. That's a little bit funky, but we're going to give it a shot just to see how it goes. Okay. So we're going to do OVS VSCTL set mirror. Can do list mirrors? Yes. Okay, so we're gonna do OVS VSCTL set mirror isolation mirror select source port equals, and then we're going to take this UUID and then select dest port This is going to be our last one here. All right, we've got a select desk port and select source port. Hey, OreoBite, good to see you. We're setting up packet capture in the Proxmox lab with Open vSwitch, and it's a giant pain. That's what we're doing. So now anything that is sent to the default gateway is going to be handled there. Let's see if that changes up what we see. Now to make this work, I may have to disable. Other network interfaces. Oh, actually, you know what? We can do more than one. That's cool. So check this out. Later in this article, it says, so far we've told Open vSwitch which ports we want to mirror. Oh no, we haven't sent it anywhere. Because we haven't done output port. Oh, okay. And incidentally, by the way, check this out. The source port, desk port, if we wanted to actually do all of them, we could do that. And that's, in fact, what I want. I want to mirror source desk across the entire switch. Do I know of Tony Robinson, DA667's Avatar Lab project? It was made 5 years ago, an entire guide. So I have that book. I bought the new version. It has exactly these problems in it, in fact. And I actually spoke to Tony about some of the stuff that he was working on, and because we were having some of the same struggles. Yeah, in particular with like Hyper-V and things like that. Yeah, we've actually chatted about that. Part of the reason why I started doing all this was because even he, who literally wrote the book on setting up home labs and things like that, found that there were things that weren't working as intended. Okay, so we're going to change this up a little bit. So we're going to do... We're going to list this bridge again. Oh, man, this is going to be cool. So now, instead of doing it this way with these select source ports and desk ports, this makes so much sense. Okay. So basically, we're going to copy everything but the final UUID here. And I think I need to put that in quotes. And then we're going to do the same thing for the select dest port. So everything but that last port listing. Uh-oh. There we go. I think you don't need to give them explicitly their select all equals true. Thank you, Trackster. But that makes a lot more sense. But I was curious, and I'm just thinking this through. I excluded the last port because do I want to mirror back the traffic that was sent to the port that I'm listening to anyway? You know what I mean? If this is going to become my destination port, don't I want to exclude that from my mirroring? Yeah, that's why I kept that one off. If I had created a second, a new interface for that. Yeah, so just to play it safe, I left that one off. But it's good to know that select all equals true is a thing. Because I believe here's the thing. Open vSwitch doesn't care about what Proxmox is doing, right? And so Proxmox has assigned these interfaces as needed. Open vSwitch doesn't care about that, so I have to care about it. And if I know that this is my like destination interface, right, I have to make sure that that thing is sending correctly. Okay. Now we have a output port. And so again, we're going to copy our last port here. And we're going to do OVS, VSCTL. Wow. OVS, VSCTL. Set mirror. Isolation mirror. Output port equals done. Still see just broadcast traffic here. See if there's a way to manually assign an open vSwitch port. Oh. So the answer is yes. Create OVS import. So I can create a specific import, but then and put it on bridge 2. But this is like a network interface. I can't, this is like for the switch, right? This is like creating an interface on the switch. That doesn't mean that I'm going to be able to connect it to a VM, right? Because if I go look at my hardware here, go to my network devices, I can add network device, bridge. I can only choose the bridge. I can't choose like what else I have going on. Yeah, that's not good. It's cool that I have a firewall here, but right, so that doesn't actually help me out. Now that assigning the VM or LXC to specific VLAN can easily be done. Right, this is how you create VLANs. Okay. How are we doing here? Still just seeing NetBIOS, MDNS. More DNS. We're not seeing anything particularly correct here. So if we go to our VM connected to VNet 2, we're going to see there's the select all. Set mirror select all equals true, output port equals port. Okay, so I feel like I'm starting to get my head around this, but ooh. So the trick is we still don't know which port is doing what. Like we don't know which output port is which. (1A 08 F1). Can you TCP dump at the OVS switch? We can, but I don't know if I need to do that just yet. Because I'm not... The question still remains. This is the question that we have to answer. How do we associate how do we associate these with network interfaces? And I thought it was, the MAC address table is one way to do it. Those defaults should be off. These are internal OVS naming conventions. Hey, Goose, my name ends in a T. Just FYI. I've been seeing that typo a bunch of times. Please try to spell my name correctly. But thank you for hanging out. So you need to find a way to correlate OVS interfaces to the IPA IF names. Yeah, basically. Or if we look at it from a Proxmox point of view, I need to see how Proxmox has configured it. Huh. BRCTL show shows me. These things. Interesting that there's a tab. Nice job, Michael. I am hoping that there's something here that can help us out. The OVS command gave us a list of IDs. 8430 webclex. Thank you for the follow. Do the MAC addresses correlate with the UUIDs? Last part of the UID is a MAC. No kidding. That was up a minute, right? It was like the FDB. What do I stream usually? So on Saturdays, 8-4:30, I do blue team stuff. And in this case, we're setting up a lab for defensive cybersecurity. On Tuesdays at 5 p.m. Pacific, I do offensive cybersecurity. So we hack stuff. And then on Wednesdays, we do programming. CE3D F2 CA. So if true, 6A-E3. I think I saw that one somewhere. I hope you're right. I hope you're right about that. That would be really cool. Okay, well, 8430, I got news for you. There's a bunch of us. CE3, F2CA, 3B9, 6927, 039, 68. A 683. C. 683C, 3BCE, 4D, 64C1A6. Yeah, I mean, they look like MAC addresses, right? But I'm not seeing a correlation here. Let me see the sock. Oh, right, it would be the MAC of the OVS port, not the host. Well, that doesn't help. 6A3. Yeah. Yeah. Okay. Let's see if Proxmox has some ways to take a look at this. Whoa. Oh, it's OpenVZ. Dang it. QM. No. Fine. All right. QM list or QM status VM ID QM status 115. That's unhelpful. Random comment. I visited Barcelona World IoT Solutions Congress last week, and a lot of smoky businesses have pivoted from blockchain to cybersec. Okay. This is really not where I want to live here. We're close, but I want to... that's not going to work. Yeah, this is for the server, not for the VM. So the question remains. Now I found this other thing where it was like Proxmox enabled port mirror, right? I found this link as well, and I haven't looked at it yet. Maybe this will clarify something. Extra hop discovery appliance can adjust network traffic modes, capture port for analysis. Hosting the EDA on Proxmox host uses Juniper to switch to mirror traffic to it from my local LAN. Okay. It's not enough to receive traffic. Okay. So this is how their lab is set up. They've got a firewall. They've got a Juniper switch. Okay. And then we've got this virtual bridge. Okay. Okay. So this is this part here is a little bit closer to what we have going on. So sort of the same deal, but the following. So they've created a tap interface created for each VNIC on a VM automatically. It is? That was an asterisk. Is there something at the bottom of this post? Proxmox is the following virtual networks: VMBR0 and virtual switches. A tap interface is created for each VNIC on a VM automatically. No, it's not. At least not for me. Is there another asterisk? That sucks. Don't have an asterisk and then don't follow up. Okay. So they're doing sort of the same thing. Select all true, output port equals P, and they're just getting the tap port. Case closed, right. This gets the packet capture working. You can now see traffic on the but does not survive a restart of the Proxmox host. Ooh, that's good to know. Or the EDA VM. Why? The command to start the port mirror is not persistent. All right, let's do this OVS vCTL list interface. Mac in use. Interesting. $680. Now this Mac in use. You just buy this interface. Yeah. So that's just a random MAC address that it's creating. It's weird. So these are not tap. These are not like manual taps. Okay. What if they're not in order? Maybe so, which means, okay, we're gonna try this a little bit differently this time. We're gonna try it with, yeah, there we go. So select all equals true. So we're gonna do something like this. VSCTL. Here we go. ID equals. Sorry, it doesn't matter because it's just a variable. Sorry, tap. Yep. Get port. Because I'm assuming that's the last port that I've created. And I do think that there is some logic here because these look like, now that I'm looking at this more, I'm pretty sure that these are the VM IDs because these are like 115 is the Suricata. This is the VM ID. So that makes sense to me. So, and this is the interface that I have for that. I didn't do something very stupid, right? Let's see. Hardware, net 2. Oh my god. Okay, that wasn't the problem, but it was about to be a problem, which was that it was on the wrong interface. See, now we have two interfaces on VM ID 115. This is starting to make sense. So this ID actually does have something in here for us. I am now very confident the output port is correct. So now we're going to do OVS, VSCTL. I think we're there. ID equals Suri tap. Get port. Paste. from there. Set mirror. Output port equals Suricata. Tap. I'm still just seeing MDNS. No, it was not ENS19. Yeah, ENS20 is our listener here. And we did the select all. So apparently, this doesn't survive reboots, which is annoying. Now, I want to try one more thing. I'm going to take this workstation and shut down its internet connection. Forcing it to go through its other route. Yep. So it only has a 10.1 now. We see IGMP traffic. It's again just multicast. We're not seeing what we should be seeing. Now, that's every... That's every port. And we're still just seeing MDNS traffic. We're still just seeing stuff that would be everywhere. This shouldn't load, period, because the thing is denied. But we're not seeing it happen. Nothing. Okay, so we've set up the mirror in theory. And we're assuming it's 115.02 or 02. That's on the wrong network, though. Did I have it right the first time? This says it's on isolation. But it's got a internet address. It's got a SecLab internal address. All right, let's disconnect it and confirm that we're looking at the right thing. Yeah, it is. More DHCP. I am 4K. Thank you for the follow. Relvain Crow, thank you for the follow. And Theo. Oh, boy. So it's up. But still not able to hear. It's connected to the right thing. Yeah, it's just getting UDP to broadcast. Okay, at this point, what could have gone wrong? Obviously, our mirror configuration here could have gone wrong. So we do OBS, VSCTL, list. List eye faces. Okay. 115.02. That's not a thing. Okay. Well, 1502 just shows that it's internal. Maybe it really is the other. So it has two of these on here, 01 and 02. We saw that this 02 only showed up when we changed up the interface, right? So if I go back to the Suricata host, notice that it's ID 115, and I change this up again, change it up to VMBR1. And go back to our console here. Notice that 01 or 02 goes away, right? We no longer see it. So we're clearly messing with the right interface. See if there's something else in here that we missed. Okay, so kind of have the same thing. So OBS CTL, they're creating a get port tap, and create the mirror. Select all these true output equals P for the tap, and then set bridge VMBR1 right. Okay, VMBR2 plainly has the mirror set up. And here are the ports that it has. Phone Tux, thank you for the follow. All right, just for kicks, I'm gonna reboot this machine in case something's up with it. Set mirror, isolation mirror. Yeah. God. Seven five. Yeah, the UUID is correct. Now, I could be wrong. But it looks like this source and destination, the select all, gave us actually too much. Because the mirror port it's mirroring interfaces that are not on the port. Right, these are the ports that I really want to bridge, or that I want to mirror, right? So we're not going to do select all is true. We're going to do select source port equals select dest, in quotes again, select dest port equals now this list of interfaces that it's mirroring matches the list of ports on the bridge. That is what we wanted before it was trying to mirror ports that were not on the same switch. I don't know that that was a problem, but probably not what we wanted. Okay, this thing is up and it has a 107. So it has an IP address on the right port. And then I'm gonna, God, it's gonna be really far. IP link set dev ENS20 promiscuous on. This is something we need to do anyway. So how do we make that happen by default? And the answer is, we can create a systemd service. So this is going to be a little bit interesting. Hey, static noise. So we're going to create a new systemd service here. Let's get rid of these extra new lines. With one of these. Okay. Type one shot, IP link set dev. ENS20. Don't need that one. What by default target? We don't need the here doc anymore. And done. Sudo systemctl enable Suricata promise.service. Boom. And now we have a tool that will automatically set ENS20 to promiscuous mode when it comes up. And we have Suricata running on this as well. And I don't think we're going to see anything interesting there, but just in case. What? What? Well, we see errors. That's different. This is the first time I've actually seen traffic in the fast log. Let's enable this thing. Let's give it a gateway. Oh, I don't want that to be true. No, it's not that it's it has the ability to be this. It's just that the firewall rules are set up. So Yeah, if I look at my isolation rules in the firewall. Yeah, because how is our LAN configured? Same deal. So all we do if we want internet traffic coming through our isolation, then apply changes. I really thought that would do it. Oh, unless... Do I have a WAN rule that says deny from... No. Yeah, but I don't have a rule, like, I don't have a rule that denies. Right? And I don't have a rule on WAN that denies from isolation. I just have block private networks. But if that were killing me, then the LAN traffic would. Oh, I have a, there we go. I have to allow an any, or allow out. No, it's pass interface isolation source isolation net destination and net. I never set this up because I never wanted it to. Apply changes, you doofus. So pfSense is a firewall for networks, while firewall D and UFW are more for workstations. Don't think about better or worse, static noise. You're absolutely right that there's a difference. pfSense is a network firewall, whereas firewall D, UFW, IP tables, those are host-based firewalls. They do different things. How's that rule set up in the WAN? It's been so long since I set this up. It's just any. Look. Gross. That's like wide open. But the WAN host is on isolation, yeah. But I'm blocking bogons. Right. Oh, you're right. Yeah, you're right. TCP is, but ping is ICMP. Right. Although... Hey, Jelly, thank you so much for the raid. I'm going to disable this first. See what we can do here. If I need to change it, I will. Welcome, friends. We are setting up a firewall to work with packet, or we're setting up a network to work with packet capture. Yeah, I'm going to have to allow. Ugh. Protocol. Any. Yeah. Fine. Yep, thanks, Trax. Apply changes every time with pfSense. I was too locked down. I'm still not hitting it. Oh, I need to enable a rule. How about that? And by the way, all of this is just to see if I can see traffic at all, which so far, no. Right? What we're trying to do is force the isolation. Yeah, that's allowed. Yeah, exactly. I should see traffic regardless of this. Right, and I am not. God, okay. Do I see traffic on the OBS TCP dump? Oh, I don't have the right Python stuff going on. Have you started the systemd service? Enabling the service doesn't start automatically. I know that's static noise. However, before I enabled the service and created it, I manually ran the command anyway. So if you see here, I do have promiscuous mode enabled for ENS20. No, our issue appears to be upstream, and unfortunately, it looks like this is not the correct Open vSwitch Python support libraries. Please. I don't know what OBS TCP dump is. You suggested it. Creates a switch, mirror port switch. And which interface do you want me to do? I mean, there's obviously traffic coming through the switch. This is right. Look at this. We're seeing traffic on that interface. No, look at that. Look at that. So 115.02, look at this. We're seeing traffic on that all over the place, right? We're seeing the mirrored traffic. This is either way. If I curl, I mean, I won't see it from here because the route is wrong, right? I won't see it out from there. But these, look at this traffic. It's mirroring traffic. Look how quiet it is elsewhere. So the mirror is in fact working. It's that this is the mirror traffic sent by the OVS switch out to the IDS switch. Yeah. Well, it's the traffic mirrored to the interface. So the question then becomes, why isn't it getting seen by the Linux host? Something I need to fix. This is a huge pain for me with NetPlan. It's a default route, but if I do... Okay. Coming in. Good. 50% packet loss. And I'll tell you why. It's because it's got a default route here. It's got competing default routes. That's why. Sudo. It's a Della remove. I always forget. It's Dell. Still getting 50% packet loss. These default routes shouldn't be there. The only one that should be there. Oh no, it's the 10 dot that's killing me. That shouldn't be there at all. I should only have out from the... 2, 3, 4. There we go. It may not be visible by design unless you create a node for it to communicate over. John, I'm not quite sure what you mean by that. This is how we're sending the traffic to the interface, and we have the interface set up in promiscuous mode. Now ping from the IDS host to the internet. See it coming in. Right, that's what we're doing. I think the PF sense IP. That I don't have. Should be an IP with 10. You're right, you're right, you're right. But it doesn't... Yeah, isolation's on 10, but... This has to work. Yeah. Hold on a second. I got to change that from a /32 to a /24. So it knows how to listen. Yeah, keep in mind, this thing was set up to not do this. I am kind of blowing away a lot of my original configurations for this to make this work. Because the whole point was to keep this lab isolated. Looks like no. There's the rule. Deny rule IPv4. .100 is not the IDS host. 100 is the desktop that we've been making noise from. Hey, look, which we now can talk to. I agree something's not correct here, Trax. ENS19 has the same subnet configured. That's true. We're seeing the replies from outside here, too. We're seeing ARP, we're seeing everything. We have the right interface. Now, your question is whether this is the right one that's connected to the right IDS, right? We have a continuous ping from the IDS host to pfSense and TCG bump. Is it seen? I can't get that to work in general. Look at that. But I am seeing... I thought I saw 10.1.99.1. Yes. Yep. We've got a tap. 115. And 115.02. Now, should we be sending it to the tap? Which I didn't, that wouldn't, we haven't seen the tap so far, but that suggests a tap interface is created for each VNIC interface on a VM automatically. But I think that's not where we send it. You know what I mean? That's the tap that Open vSwitch is using to get the traffic. I know what you're talking about. Yeah, it does. So it's there. Problem is on the OVS side. How do you figure? If we're seeing the traffic come out, you're saying that's not going back into the right port. All right, let's see then. How did this person set up the output port? Tap. It is going to the tap. So there's this secret tap port. Tap interface is created for each VNIC on a VM automatically. Tap interface have the new format. Tap VMID. Interface number. So how are they doing this? So one second, Trax. I'm going to read this command. ID equals P, get port, tap. So they're just looking for the tap right away. And then create mirror, select all equals true, output is the tap. Okay, but we don't want to do that exactly because we want to have the ports as we isolated them, right? And then set the bridge. Okay. So the trick is this tap thing, which... Indeed it does. 115 I2. So we're going to change this. I hit Control W, which is a bad idea in this case. We're going to send all the data there. Oh, for the love of God. Why won't it save the one that we do successfully? Oh, no. It says no row tap 115 I2 in table port. It says get port. Yeah. One 115 I2. So this just seems wrong. I1 get port tap PMID I1. That's a hook script. There will be. Get port tap. Because we don't see the ports listed. Or so we haven't seen the taps listed. And this is also not what we saw with this, right? Because it didn't talk about taps at all here. In this tutorial, it was talking about, we just have these ports, right? On this bridge, we have these ports here. And then here it's getting the port VNet 0, which was just one of the basic interfaces, right? That's traditional bridging. So I'm not sure what this is about because we plainly can't identify the tap port here. God, I hate this stuff. I hate getting stuck on the stuff like this. Open switch has a network device contents. Temporary. Internal ports in the OVS user space should not be used. OpenView switch connector is called tap. This is intended only for internal ports in the OBS user space switch and should not be used otherwise. In particular, users should not configure KVM tap devices as type tap. Use type system, the default instead. Okay, so we can't use that tap. It doesn't appear to be what we're supposed to be using. Yes. ESCTL. List. And it wasn't in list iFaces either. Okay, so still think there is a general problem in OBS because remember it is sending out traffic which is not reaching the IDS host. Also, the ping did not come back to .107. I don't think that's a problem with OpenView Switch. I think that's a problem with pfSense, to be honest with you. Because if I do 10.1.99.3, that works. Yes. I lied. I think the issue is about the interface, 10.1.99.1, the gateway. And I don't really care about that right now. Because it's plainly able to get to other things on the local network. Now look at that. We saw ARP. Right. Did we miss a step? The answer from 107 didn't go over ENS 20. No, it didn't. Yeah, I understand that. Okay. Getting a little frustrated. And I gotta call it soon, but I just want to make sure I didn't miss something simple in 2, 4, capture. Let's see if I did something dumb when I was setting this up. Yeah. Should I not have promiscuous mode enabled? Yeah, that's what I thought. Yeah, otherwise the stack would drop while package done. Yeah, that I agree. It's not strange that the 107 reply did not come over ENS20, because we have two interfaces on that subnet. And one of them has a route and one of them doesn't. Or one route has a higher priority than the other. This is just man pages. I don't care about that. See if that helps. This will be done automatically when executing TCP dump as root. Okay, the issue seems to be that we're mirroring traffic to this interface successfully. This thing that we're calling 115.02. This traffic is getting mirrored successfully. This is working. The problem is this interface the one that we're connecting to our Linux machine? We believe that it is because when we... Right. And assume it's the NS20. That's what I'm saying. And the reason we believe that, don't forget, is because when we did... when we did this, right? When we took that interface off, this interface went away. When we took ENS20 off, this interface went away, leading us to believe that indeed was the interface that we're talking about. And yet, yeah, tap doesn't work. Three interfaces. One of them is on the SecLab internal default internet network. One of them is a static IP on the in the isolation lab, and the third one is the DHCP controlled, but whatever, on... There are only two because one of them is on the other switch. If we were to list ports on VMBR1, we'll see a 115.0.0. And that's the other interface on that machine. So here we have these two interfaces. This one Yeah, it's up. Okay. It's got an IP6 address for some reason. Can you TCP dump any on the IDS host? Let's see if the... It is. $19. That doesn't make any sense. When we took that machine down, the interface has changed. Unless it's dynamically renumbering them. That's got to be what it's doing. It's dynamically renumbering them. So we have them both up. For whatever reason, now 01 is the right one. All right. Now let's see if it's coming in on 20. Are you kidding me? Oh no, there it is. That's just ARP again, though. So we set it to mirror everything, and for whatever reason, it didn't like 01. I'm not trying 0. Is 0's on a completely different bridge? I'm setting it back to see if there's any difference. Okay, so in this configuration, let's seize the domain controller. Seize broadcast. Right, this should be picking up data, right? From either one of these. And this is CNN. This is going to be sending me all kinds of stuff. But I'm not seeing it on either one. Now it's just SSH. So it's not doing. Yeah. This is it. Look, we're sending, look, O2. That's got to be the CNN data. Look at that. And it's going to 10.1.99.100. That shouldn't matter, but just in case. No. Is it possible that the network adapter does not have the capability to do this? I gotta bring IP link up. I gotta bring the IP link up. Right. Sudo IP link set dev ens20 up. Thank you. In ESX, yeah, you can set promiscuous for a VM. That's right. This is the whole thing. Like, we're trying to do this with Proxmox rather than anything else. That's not better. Oh, but okay, so let's try that again, and then let's also see, because we had that weird thing where we found the traffic on 19. Or no. Again, we see the MDNS. And nothing else. Okay. I am afraid I'm going to have to call it here for now. MDNS is not directed traffic. It can't be. The whole thing is that it's looking for host names. So yeah, I think we're gonna have to call it there. It's been a long stream. We've made some progress. There's definitely still some more to suss out, but we're getting closer. I know this is a long slog, and thank you everybody for sticking through it. Hopefully once we get this all figured out, we'll have a nice clean procedure that we can then not have to go through all of this again. But for now, let's see if there's anybody else who's streaming that you can enjoy. Ah, perfect. Luca is streaming. So we're going to set that rate up, and I will be back on Tuesday doing some Red Team stuff, not this, if you're interested in that. So thanks, everybody. And Trackster, thank you so much for all your help. Really appreciate it. Until next time, friends, please be good to yourselves, be good to each other, and happy hacking. Did that not work? There we go.